Hey there, welcome back. So, we're getting near the end. We just have this episode and the next one left in this course. So, we just have a little bit left of assembly language specific things. And then we're going to move over to NESmaker specific things. So, today we're going to be talking about two things. The first is bit manipulation. That's the last assembly language specific thing. And like I said, after that we're going to be moving over to NESmaker specific things. Today we're going to be talking about script settings and look at where we can find the different things. And in the next episode, we are going to be looking at more advanced things. So, bit manipulation. Before we talk about that, we need to do a quick repetition when it comes to binary numbers. This has to do with binary numbers, so we have to be absolutely sure that we know how that works. So I've I made a little thing here. So you remember that 1 byte, that's 8 bits. And of course, you remember we have 3 different number systems. Binary, zeros and ones. We have the normal decimal number, 0 to 255. And then we have the hexadecimal system, 00 to FF. So here I've set up a byte like this. And because there's a percent sign in front of it, this is a binary number. I put these red dots underneath here because now we're going to look at each of these bits as a switch, like an on-off switch. Right now all of these are 0, so they are off. That's why they are red down here. If this was a 1, there would be a green light here on the top, so that switch is on. So it's just to show you that we can think about these as switches. And also, let's not forget the numbering of these bits. So this is a byte, 8 bits. Now, like I said a while back, the numbering is maybe a little counterintuitive in that we start counting from the right. So this is bit 0. This is bit 1, this is bit 2, this is bit 3, and so on. We start counting there on the right. And of course this will be bit 7. So that's probably useful to keep in the back of your head that this is the number system, or that's how we number these bits. Alright, so we have this byte, 8 bits. So let's try to do something really simple. Let's just start counting from 0. Start counting from 0 to 10. And then we'll look at these numbers and see how they change. Now, like I said, this is about the binary numbers, so this is the important one. But you can also notice the normal decimal over here and also the hexadecimal over here. So this is 0. This is how 0 would look. Let's go up to 1. That's the number 1. We have a 1 here, and since this is a number 1, we have of course 1 in decimal and 1 in hexadecimal, so not so very complicated. Let's go up to number 2. Now we have 1 here in this is bit 1, right? 0, 1. Now we have 1 here. Now we also have to remember that each of these bits represents a value. The rightmost bit, that's 1. Then the next one, that's the value 2. The next one is 4, 8, 16, 32, 64, and 128. That's what those bits represent. So now we have a bit here in the value, in the position that has the value 2. 1, 2. And then it just doubles as we go along. So now there's a 1 here in the 2, where the 2 value is. So let's go up to 3 now. So now we have a 1 here in the where there's a 2, and there also is a 1 where there's a 1. So 1 plus 2, that's 3. This is the number 3 in binary. Okay, so let's go up to 4. This is number 4. So remember, each of these has a value 1, 2, 4. Okay, so this is value 4. Then we have 5, 6, 7, 8, 9, and 10. Let's also notice over here that the number 10 in hexadecimal system is A, 0A. Because in hexadecimal we go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So 10 in normal decimal, that's A in hexadecimal. But we're going to focus on binary now. So this is the number 10 in binary. We have switched on this bit and this bit. So that's binary numbers. That's how they work. All right, so now let's take a look. Like I said, this is just a quick repetition. We have decimal numbers, like I said, from 0 to 9. That's how we count, or 0 to 255 actually, like we're seeing over here. But we count from 0 to 9 for 1 digit. So that's what we've got going on here. For hexadecimal, it's 0 to F, or if we are looking at the byte, it would be 00 to FF. So FF is 255. In binary, we have this. We go from 0 to 1. So this number in binary is 255. So, like I said before, these numbers are actually the same. They just look different based on what number systems we use. You can use whatever number system you want. It doesn't change anything. But sometimes it might be a little bit complicated if you're going to use hexadecimal systems, where you just say, draw this sprite at position 10, and you forgot that 10 in normal decimal is not the same as 10 in hexadecimal. So when you write 10 in hexadecimal, that would be 16. So if you want to draw a sprite 16 pixels to the right from the left edge, and you write 10 in hexadecimal, well, that's 16 in normal decimal. So like I said before, they each have their own uses. Whenever there's not a reason for me to use something else, then I'll just use the decimal number system. Even though oftentimes you'll see both in NESmaker and probably a lot of examples online too, that a lot of people just use the hexadecimal system all the time. But we can use whatever number system we want. It doesn't matter. Now today, like I said, we're going to be focusing on binary. So this is the important one for us. So today we are really going to see why, or when binary becomes really useful for us. So you may remember that I said we can use 1 byte in our game to keep track of 8 power-ups, because we can look at each of these bits as a switch, on or off. Do we have this power-up? Do we have this power-up? Do we have this power-up? And so on. So we're going to take a look at that a little later in this episode. But anyway, you have to be really comfortable with these number systems. And today we're going to look at binary. Okay, so we looked at this. We have this bit 0, 1, 2, 3, 4, 5, 6, 7. Start like that. But we also have to remember that each of these represent a value. And we add them together, like if you have a 1 here and a 1 there, then we add these numbers together. So this is 1 plus 2, so this would be the number 3 in binary. So, but sometimes, like I said, with the power-ups, we don't really care what number this is. We don't care about, okay, this might be number, I don't know, 147 or whatever. We don't care about that. This time, I'm just going to use this byte, like I said, with a bunch of switches. So, I could say that, let's say this was this power-up system. This was one power-up. So now I collect this power-up, well, then I put a 1 there. Now I got another power-up, oh, well, that's this power-up, so we need to put a 1 in there. So we need to have a way to do this in assembly language, to just like enable these switches. Now I just want to set this switch or this bit to 1. Now I just want to set this bit to 1. So we need to be able to do that in a very elegant way. So in this case, we're not too worried about what number it would represent in the end. Don't care about that now, because we're using this byte a different way. You could say it's still going to be a number, of course, but we don't care about what number that is. So in order to do this, to set those bits, to check if those bits are set, that's what we call bit manipulation. You need to manipulate different bits in here. So first, let's look at something called AND. This is a sort of a logical operator where we say, let's say we're comparing two bytes here. We have this byte and we have this byte. These are 2 bytes. So we're comparing those and the result is down here. So when we're comparing using AND, we have 1 byte here and 1 byte there. When comparing those to each other, this byte compared to that byte. So how do we do that with AND? Well, first let's look at this from a conceptual point of view. Then we're going to look at the code later on. But the way this works is that we're comparing this bit to this bit. And when we're dealing with AND, it works like this. 1 and 1. That's a 1. If there's a 1 here and a 1 here, then there will be a 1 down here in the result. So let's just do it like that. So if there's a 1 and we say AND with another 1, and that's a 1. Now let's continue with the next bit. There's a 1 here and there's a 0 here. When we're using AND, 1 and 0, that's a 0. So it's only going to be a 1 if there's a 1 in both of these bits. If there's a 1 there, there's a 1 there, that's a 1. If there's a 1 here and if there's a 0 in any of these, then the result will be 0 for that bit. So it doesn't matter if the zeros up here or there. If there's 0 in any of these, then it will be a 0. So it needs to be a 1 in both of those. So like we're seeing here, 0 and 1, that's a 0. 0, 0, that's of course 0. And 1, 1, well, that's a 1. So that's how AND works. there has to be a 1 here and a 1 there in order for it to be a 1 down here. If there's a 0 in any of these, then the result will be 0 here. Now, when we're talking about it like this, it's probably a little bit abstract. It's like back in math class. You don't really see what you would use this for. But trust me, it's going to be useful later on in this video. So, right now, we just need to understand that when we're using AND, it's a 1, and if there's a 1 and a 1, then that's a 1. If there's a 0, and we're comparing, and that's a 0. So it has to be 1 in both of those. Right, that's the AND. Like I said, we're going to come back to why we need to use this later. So that's the AND system. Now, let's look at the OR system. So we have AND, logical operator, and then we have this OR. So OR works like this. Again, we start here on the right side with bit 0. Start here. So if there's now we're using OR. If there's a 1 here or a 1 here, well, that's a 1. Right, next bit. There's a 1 here. There's a 0 there. 1 or 0. That's a 1. So when we're using OR, it's enough if there's a 1 in one of these. Now it will also be a 1 if there's a 1 in both, like this. But if there's a 1 in this or this, is this 1 or is this 1? Well, there's a 1 up here, so the result is a 1. So 0 or 1, well, there's a 1 down here, so that's a 1. 0 or 0, well, that's a 0. So if there's a 0 in both, when we're using OR, 0 or 0, that's a 0. So in this case, as you can see, if there's a 1 and a 1, then there's a 1. And also, if there's a 1 in one of these, then there's a 1. So it will create a 1 in this and this and this example. It's going to create a 0 only if there's 0 in both of those, like we see here. 1 or 1 is of course 1. So again, probably a little vague just looking at it like this, but it's very useful to understand exactly how this would work, because we need to keep it in the back of our heads when we are going to use this in assembly language. 1 or 1 is 1, 1 or 0 is 1, because there's a 1 in one of those. And if there's a 0 or a 0, that's a 0. So, and or. And or. These two are very useful for us. So now, how do we use these? Okay, let's take a look at this game. This Cody's Quest game. You've already seen it. Let's take a look at this game now. Okay. There we go. So, Cody's Quest. Now, I've changed it a little bit since last time. Now, when I start the game, there are actually 2 power-ups here, right at the beginning. Now, the first thing I want you to notice is that I have a sprite HUD up here. So, this blinking shoe up here, that's the double jump shoe. Right now, I just have normal jumping. I can't double jump. I want you to notice up here, when I pick this power up, when I pick that up, notice up here. I picked up that jump shoe, and now it's displayed here in the HUD. Not only that, but now I actually do have double jump. I couldn't do this before, but after I picked up this power up, now I have a double jump. So that's cool. So there's this other power up, that's a jetpack. Again, notice this sprite HUD up here when I pick this up. I picked up the jetpack, and now it's displayed here with the shoe up in the sprite HUD. And now, after picking up this jetpack, I can click the select button, and now I have a jetpack. That's cool too. So now I have these cool power-ups where I can double jump, I can use this jetpack, and the way I'm doing this is with OR and AND. These logical operators. So how does this work in assembly language? Well, first of all, let's go to the pickup script. So let me go to script, project settings, script settings over here. And I'm going to open up the pickup script here. So already we're moving into the territory because today we're going to be looking at script settings as well. So we have already begun doing that now. Here's the pickup script. Game pickup script. So when I select that, click edit. This is my pickup script. Now this is a custom one that I made. Now the pickup script works like this. The way it's set up by default anyway. It starts by, say, LDA object type, X. So we're checking when whatever object is in the code at this point, X. So whatever object has reached this point in the code, what object is that? That's what we need to check. So we start checking here. Compare with 3, is it game object 3? Is 0, 1, 2, 3, is it this one? And then I say, well, it's not that one. Branch if not equal. I go down here. Then I compare it with the next one. Is it game object 4? No, it's not that one. So I just keep checking like that. So I go down until I get to, let's look at the double jump shoe. That's almost at the bottom. So 15, 14, this is game object 13. So I have that all the way down here. Here is where I check for the double jump shoe. So if I pick up an object, it goes through these checks and it checks for these numbers, and yes, this is game object 13. Alright, so it's game object, and by the way, you know about this, right? In order to make an object a pickup object, we have to check this, click that checkbox. But anyway, what happens when I collect that shoe? Well, if it's not, of course we go down here, but if it is the shoe, then I go down here. And this is what I do. I say LDA power-ups. Now power-ups, of course, that's a variable, a user variable that I made over here. I just made a user variable. So that's a variable. And I also said what each of the different bits should represent. I decided that this bit 0, that's going to be a double jump shoe. Next bit, that's going to be a jetpack. So I just decided for those first two there. So what I do, I say LDA power-ups, load whatever's in that variable right now. Load that into the accumulator. And then I say, or A, ORA. That's this OR we were just looking at. That's this one. So what I'm saying here, load A with power-ups, OR it with a 1 in here, and then store it back in the power-ups. What's happening here? Well, it's kind of hard to see when we write the name of the variable like this. So let me try to write it a different way. LDA. Let's say this is the beginning of the game. I haven't picked up any item. I have nothing. So the variable power-ups, that would be 0, 0, 0, 0, 0, 0, 0, 0. Right now, that variable is 0. So what would happen if I said, like I do up here, if I say ORA, so I'm ORing it with a 1. I should probably, let me do it another way. Let me do it this way. So it becomes more clear. So what I'm doing here, whoops, sorry. There we go. Okay, so let me write it this way. Power-ups right now, that's 0. I'm ORing it with 0, 0, 0, 0, 0, 0, 0, 1. And then I'm storing it back in power-ups. Okay, so 0, all of these zeros, and then a 1. Let's go back to the Excel spreadsheet here. I'm gonna set a 0 in all of these now. So let's say this is my power-ups, or yeah, it's just called power-ups. This is the variable power-ups right now. I'm ORing it, like you see in the code, I'm ORing it with a 1 here, way over there in bit 0. Okay, that means we have a 1 here now. So I'm ORing a 1 with the contents of the power-ups right now. Do you remember what I said just a few minutes ago? 0 and 1. That's a 1. When we're using OR, 0 and 1, that's a 1. As long as there's a 1 in one of these, and that's a 1. So basically what I'm doing here, and I'm storing it back into power-ups. That's what's happening here. Right now, power-ups is 0, but I'm ORing it with a 1 here, and I'm storing it back in power-ups. So I'm loading the value of this power-up into the accumulator. So I'm ORing it with a 1 inside the accumulator. We're still inside the accumulator. First we're loading this power-up, or this variable, loading that variable into the accumulator. Still inside the accumulator, I'm ORing that with a 1 here. Now I've done that inside the accumulator. Now I need to store the result back somewhere. So I'm storing it back where I got it from, the variable power-ups. So in other words, now the power-up looks like that. I've flipped this first bit by ORing it like that. I flipped that bit. So like you saw in the definition here, let's see, power-ups over here, I decided that that bit 0 over there, that's going to be the double jump shoes. So I need to set that bit to 1 in order to keep track of, do I have that power up or not? 0 or 1. Well, I just picked up this shoe, so now I have it. So I need to flip that bit to 1. And that's what I'm doing when I'm ORing it with 1 like that. Again, 0 and 1, that's a 1. In other words, now I have the power-up shoes. It's stored here in the variable power-ups. Okay, now of course this alone is not enough to do some double jump. We have to do some other code in the background, or in addition to this. This is just flipping a bit. But this is a nice way to keep track of, do I have that power up or not? I just ORed it with a 1 here, so now I have that. What about this jetpack? What about the jetpack? Let's look at the other power up. Let's say that now in my pickup script here, I pick up game object 14, which is the jetpack. Now I'm picking up this. Again, a pickup object. So we run the pickup script and we find out, yeah, this is the jetpack. So what happens in here? Well, as you can see, again, I'm loading power-ups, that variable, into the accumulator. And I'm ORing it with not a 1 here, like I did with the shoes. Now I'm ORing it with a 1 here. So if we go back to the Excel spreadsheet, this is how my power-ups look right now. First, there was a 0. I didn't have any power-ups. And I pick up the shoes and I flipped this bit to 1. So now we have the power-up shoes. Now I'm picking up the jetpack in addition to the shoes. I'm not going to replace whatever values in there. I need to be careful not to overwrite or delete something. I need to keep track of both of these. So I can't do anything to, I can't say load A with 0, store it in power-ups, because then I screw this up. We're just flipping 1 bit at a time. So here is my double jump shoes. I have that now. Now I'm picking up the jetpack. And like I said, here I'm ORing it with my my power-ups looks like that now, because I got the shoes just a second ago. So now I'm ORing that with this. I'm ORing that, whatever's in my in power-ups right now, ORing it with this number. So I'm ORing it with that. That's what I'm doing here. ORA, that binary number with a 1 right there. So I'm ORing whatever, that's what my power-ups looks like now. This is my power-ups right now, because I have the shoe. So I'm loading A with this, and I'm saying OR with this number now, and I'm storing it back in power-ups. So ORing this number with this number. Let's start here on the right. 0 and 1 and 0. Oh, there's a 1 in one of these. When I'm using OR, As long as there's a 1 in one of these, that's a 1. So that's not going to change. 0 and 1, well, there's a 1 in one of these, so that's a 1 here. And the rest of these are zeros, so 0 and 0, that's always 0 when we're ORing like this. In other words, I just flipped this bit now, because that's the bit I decided to use as the jetpack. So I'm flipping this bit from 0 to 1 by doing it this way. So like I said just a moment ago, it looks a little abstract and it looks like math class when we're just looking at this spreadsheet. But if we can understand how this works, then as you saw in the game, we can do some pretty cool stuff. And we can have 8 power-ups just by using 1 byte like this. Because we're just flipping 1 bit inside there at a time. Now we need to be really careful now, because when I'm ORing it, I need to OR it with exactly the correct bit. So as long as I'm writing a 0 for the rest of these, then that doesn't matter. We saw this just a second ago. I already have a 1 in here because of the double jump shoes. So I'm ORing a 1 with a 0. That's okay. It's not going to change anything, because 1 and 0, that's still a 1. So that doesn't change. But 0 and 1, that's a 1. So this one is going to change now. 0 and 1, that's a 1. So just by ORing it with a lot of zeros and a 1 in the bit where you want to flip it on. We are flipping the switch to on now, from off to on. 0 and 1. So this is bit manipulation, like I said. Flipping these bits on or off. Now we haven't looked at off quite yet. Let's just look at this on, turning it on first. So in assembly language, the mnemonic for this is ORA. Or I'm guessing it stands for OR accumulator, because we're doing this inside the accumulator. So that's how we flip bits on, just by using OR like that. So maybe you need to practice it a little bit, but once you understand the concept here, it's really not that hard. So in terms of saving space in memory, because all of the 8-bit systems, none of them have a lot of storage. So if we can store 8 power-ups in just 1 byte like this, and that's great. So that's a really good idea to do it that way. Okay. Well, let's say that we're satisfied with turning on. But let's say that there was this cutscene where there was this evil guy, and like if you have played Symphony of the Night, at the beginning of Symphony of the Night, you meet the Grim Reaper, or you meet Death, and he takes away all your weapons. You have all these cool swords and all that stuff, but it takes all that away from you. Let's say that happened in this game now. How would we program that? We looked at turning these bits on right now, just a second ago. So we know how to turn these bits on. How can we turn them off? Right? So now we need to go back to our spreadsheet. This is how we turn bits on, by using OR like this. We're ORing with 1 in the bit we want to enable, the bit we want to turn on. Like for example, if I OR this one, then I would basically enable turn on this like that. So we know how to turn bits on. How can we turn them off? Okay, let me reset this. Zeros all over the place. And let's see. This was something I just... So let's do this one. Zeros there. So this is power ups. And power ups. So I'm saying LDA, STA. Now this is turning a bit off, setting it to 0. So right now I picked up the double jump shoes, that's this bit. I picked up the jetpack, that was this bit. So this is what my power ups variable looks like right now. The byte inside power ups looks like this now. A 1 in here because of the double jump shoes, a 1 in there because of the jetpack. Right, so now death comes into our game. Grim Reaper. Now he comes and he takes away my double jump shoes. And yeah, okay, let's just say he takes just the double jump shoes. He allows us to keep the jetpack. So now we need to turn that bit for the double jump shoes off. How can we make sure that this bit is set to off or 0? Can we do that with OR? Well, if there's a 1 here in power-ups and we OR it with a 0, that's not gonna work, because when using OR, 1 and 0, well, that's still 1. So that doesn't work. We can't use OR for this. So we need to use AND for this when we want to set a bit to 0. I want to disable the double jump shoes here. So when I'm using AND, right now it's set to zeros all over the place. Let's see how that would work. So we're using AND. There's a 1 here, there's a 0 there, 1 and 0. That's a 0. 1 and 0, that's a 0. 0 and 0, that's a 0. So we're using AND. If there's a 0 in one of these, then that's a 0. Because when we're using AND, there needs to be a 1 in both in order for it to be a 1 down here. So if I wrote this code, load A with power-ups, this number, then I say AND with zeros all over the place, well, that would result in this. So if we wanted to completely clear all power-ups, we could do that, yeah, sure. But like I said, in this case, I just want to disable the double jump shoes. This one. I want to keep the jetpack. So the way I would do that when I'm using AND was this, using it this way. Loading with ones all over the place here, except where I want to turn that bit to 0. So let's try take a look at how this would work. LDA. Then we start comparing because we're using AND. 1 and 0. That's a 0. Okay, so that worked. 1 and 1. That's a 1. 0 and 1, that's a 0. 0 and 1, that's a 0. So what happened now is that I actually disabled the double jump shoes, and I kept the Jetpack. Because I only set a 0 here where I wanted to make that bit 0. So I could do the same thing. Let's say we wanted to disable only the jetpack. We're gonna keep the double jump shoes now. Well, in that case, we would have to AND it with a 0 there. So now start comparing using AND. We start comparing here. 1 and 1. Well, that's a 1. 1 and 0. Well, that's a 0. 0, 1, 0, 0, 1, 0. So now I have only disabled this bit. I've only disabled the jetpack. And by only setting a 0 there, I kept these other values. So for example, if I had the power up over here as well, then I would have kept that as well. 1 and 1, that's a 1. So I'm setting ones all over the place, I'm ANDing with the binary number ones all over the place, except where I want it to be 0. That's I need to put a 0. I need to AND it with a 0 there. So that's how we can enable bits by using OR. And when we're using OR, we just say something like that. ORing it with a bunch of zeros, and we're setting a 1 in the bit where we want to enable that. In that bit we need a 1. The rest will be zeros. Now if you want to, like I said, disable a bit, turn a bit to 0, you do almost the opposite in a way. But we're using AND, and we're using ones all over the place except for 0, where we want to make that bit 0. Okay, so I hope this makes some kind of sense. We need to understand how the OR and the AND, logical operators, how those work. So once we understand that, how we can flip bits on or off, then we can use that, like we're seeing here, in our code. And in this case, I'm using those to keep track of power-ups. Now this is just one of the uses. You can do a lot of stuff. In fact, that's a lot of what you would do in complex assembly programming, for example. When you're working with hardware, you have to modify these different special memory addresses. Then there's a lot of this stuff. Enabling bits, disabling bits inside just one byte like that. So it's a pretty important thing to learn. Okay, so let's go a little further here with this code. I've enabled and I've disabled. We looked at how we could do that, but that's just for this byte, or that's just for this pickup script. I'm just enabling the different things based on if I pick those objects up or not. Here I pick up the double jump shoes, so I enable that bit. Okay, so I pick up the double jump shoes, but how can I double jump? Well, we're not going to look at the code exactly for how to do double jump. I have a tutorial for that on the forum. So we're not going to be looking at that exactly. But if you think about it, okay, so we have enabled double jump shoes. How can we check it, and where can we check it? We're talking about jump. So we probably need to check the jump script. So I'm gonna go to input scripts here. And let's see, jump through plat. This input script, jump input script. So if you look at this, like I said, let's not focus on the actual double jumping, because the main point here is to understand and or, how we use those. So here in my jump script at the beginning, almost at the very top, I say LDA power-ups, this variable that keeps track of my power-ups. I'm loading that, then I say and, with a 1 there, because that's the bit for the double jump shoes. Okay, load A with power-ups and, okay, now what? Then I say branch if not equal got jump shoes. Huh, alright. So I don't have any compare in here. You know what that means, don't you? When I don't have a compare and I say branch this, branch that, what does that mean? Well, we talked about this before. It means we actually have a compare with 0 in here. If we don't write compare with anything, then it means compare with 0. And like we talked about, we never really need to write compare with 0. So if you don't write compare with 0, that's what we've got going on here. So load whatever's in power-ups and it with this. Okay, let's go back to the let's just do it that way. All right, so this should be correct now. Let's see. Now this is what I'm doing here in the code. I'm loading whatever's in power-ups right now. Load that into the accumulator. And it with a 1 there, bit 0. Okay, so here's bit 0, anding it with a 1 there, because this bit is the double jump shoes. We probably know that by now. Why do we and it with a 1 there in the jump script? Well, this is a way to check if that bit is set or not. 1 and 1, that's a 1. Yeah, 1 and 1, that's a 1 when we're using and like this. Okay, why do I do that here? 1 and 1, that's a 1. Remember, you have a compare with 0 here. 1 and 1, that's a 1. That's a 1. 0 is not, a 1 is not a 0. We have a 1 here, not a 0. So here it says branch if not equal. Is it 0 or not? It's not 0, it's a 1. Alright, if it's a 1, branch if not equal, go here, got jump shoes. So then I perform some code here for the double jump. So the point here is that, and remember, now I'm just going to remove this compare with 0. So we just have to remember that when you see some branch stuff and there's not a compare in front of it, then you're comparing with 0, which is what we're doing here. Load a power-ups, and it with a 1 there. Branch if not equal. Okay, so branch if it's not 0. Alright. 1 and 1. That's not 0. Alright, so we go here. So that's how I check if there's a 1 in that specific bit. I check it like this, and I get this result. Because basically you can put a 1 in here for whatever bit you want to check. This time I was checking that. If I wanted to check for the Jetpack, I would have to say load A with power-ups and it with a 1 there. So when I load this, and it with this, look at this AND number, there's only 1 in here. So only here, that's going to be a 1. Load A with that, and it with that, well, that's a 1. So that's not 0. So again, we could have used this. Let's just look at the script where I change into the Jetpack. Here. Again, we're not going to go into some Jetpack code here. We're just going to look at how I check if I have the Jetpack or not. So I'm doing the same thing, loading A with power-ups, my variable. Now I'm ending it with a 1 where I know the Jetpack is, the bit for the Jetpack. I have a 1 there. Load A with that, and it with this. Is there a 1 there? Because if there's a 1 there, then it's going to be 1. It's not going to be 0, right? 1 and 1. Yeah, there's a 1 in there. Okay, branch if not equal. Branch if it's not 0. Well, I got the Jetpack, right? So I go down here and I do this Jetpack code. Now, if I didn't have the Jetpack, if I only had the double jump shoes, there would only be a 1 in here, right? So I got to this code, load whatever's in power-ups, and it with a 1 there. Okay, so we're ending it, let's see. We're ending it with a 1 here. Alright, 0 and 1. That's a 0. Huh. So I don't have the double jump shoes. 0 and 1, that's 0. We're using AND. So I check the bit here by saying AND there. And 1, 0 and 1, that's a 0. So it is 0. Okay, again, just to make it clear. Load that, and do it to that. Is it 0? Yeah, it's 0. Alright, then we're not going to be doing this. Because here it says branch if not equal, if it's not 0. But it is 0. So we just continue on, and then we get to this, RTS. And you know what that is, right? Return from subroutine. So we're just gonna exit the rest of this script. So this is just a way to check that bit. And only if there's a 1 at that position in power-ups, only then do we continue on here. Else, just do whatever's in here. You're exiting in this case. So I hope you can see how we both set or disable or flip switches on or off inside the byte, and how we can check the different bits in there, and how that could be useful, for example in this case, like checking for power-ups and stuff like that. So yeah, I think that's enough for the bit manipulation. So I had planned to talk a little bit more about script settings in this episode. Project settings, script settings. But this episode has run for quite some time, so I think we're approaching an hour or so. So I'm gonna dedicate the next video to working with this. And actually that works out pretty well because we're still going to using script settings in the next episode. So the next episode is going to be almost 100% NESmaker specific. We're going to be talking about where we can find the different things here in script settings. If you want to work with gravity, if you want to work with pickup scripts, or Hertz scripts or whatever. And we're going to take a little look at bank switching, which is a pretty complicated topic, so we're probably not going to get too deep into that, but I just want to at least briefly show you how bank switching works, because as you can see, there's a lot of banks here in NESmaker. So I think we'll save all of that for next time. So next time we're going to be looking at script settings and all these other things as well, of course. So I think we'll say that that's enough for today. So I hope that you have a great day, and I'll see you in the next video, the last video in this series. Have a great day. I'll see you then. Bye bye.